All right, so we kind of already did this RL circuit in the past when we were looking at transfer functions, so I'm not going to mess around with taking too much time to derive this transfer function. Instead, I'm just going to paste the phasor domain circuit that we found previously right here. Of course, we know the impedance of an inductor is j omega L, and then this is the transfer function that we got, which doesn't look exactly the same as what I have. Let me resize this and just throw it right here. Doesn't look exactly the same as what I have boxed here, but I just did some algebraic manipulation, divided the top and the bottom by this j omega L over R to get it into this form here to make the math easier. And so if you remember what we did previously for the RC circuit, we just started with this V out over Vs that we found, our transfer function, except we want to multiply the top and the bottom, right, by the complex conjugate to get rid of this j in the denominator and sort of to give us the complex number representation in rectangular form so that we can then do the phasor equations and find our magnitude and phase for our frequency response. Okay, so let's do that first. Multiply by 1 plus j r over omega L on top and bottom. That's our complex conjugate. And so what we would get on the top is just 1 plus j times r over omega L. And then that divided by, and then of course, I'm not going to go ahead and do the FOIL again. Hopefully you can do it yourself by now. On the bottom, I'm just going to get 1 plus r over omega L squared. Okay. And so from here, now I can separate this into real and imaginary parts. I can say V out over Vs is equal to 1 over 1 plus r over omega L squared plus j times r over omega L divided by 1 plus r over omega L squared. All right, so again, we have our real part here, we have our j here, and we have our imaginary part here. And from here, we can go ahead and find the magnitude of this complex number. So let's go ahead and do that. So the magnitude of V out over Vs, of course, we know that it's just going to be the square root of the real part squared plus the imaginary part squared. So in this case, the real part is 1 over 1 plus r over omega L squared. Take that whole thing and square it. Plus r over omega L, right, divided by 1 plus r over omega L squared. That whole thing is squared. All right, and so again, the common denominator is 1 plus, right, we have our common denominator here, same thing here and here, so we can just add the two numerators to give us a single fraction here, which in this case is going to be 1 plus r over omega L squared divided by 1 plus r over omega L squared squared. We get one of these to cancel. This whole thing cancels with one of these, and we're left with a magnitude of the square root of 1 over 1 plus r over omega L squared, which I can again rewrite as the square root of 1 over 1 plus r over 2 pi fl squared. All right, so that is our magnitude for our RL circuit here. I'm going to go ahead and put a box around it. Hopefully this process is starting to feel a little bit redundant. I know we've only done one example, but pretty much the same process here. Now we have our magnitude, and we're going to go ahead in the next video and find our phase. So once we find our phase, then we can plot the magnitude and the phase, obtain the frequency response, compare it to simulation, and then we're going to be on our way. So I haven't gotten to Bode plots yet. That's the next part of this module. That is going to be the standard easy way to draw the frequency response, which doesn't require us to do point by point. It still requires us to obtain the transfer function, the magnitude, and the phase like we're doing right now, but it does not require us to go point by point and plug in values of frequency. Rather, it just allows us to obtain the frequency response pretty quickly directly from the cutoff frequency and some other pieces of information. Okay, but I just keep mentioning these Bode plots because they're coming, they're around the corner, but we're just not getting there yet. And they're very important, and this is all motivation for the Bode plot material. Okay, so I'm going to go ahead and end this video here, and in the next video I'll go ahead and find the phase of this RL circuit, the phase of our transfer function.